My name's Tony Wright. I'm the Divisional Director for Upgrade Market in the UK for ebm-papst. First of all, thanks very much for inviting me to speak today. We've heard some really great presentations so far about how you can retrofit different technologies into supermarket applications, and I'm going to talk really about fans in supermarkets. It's great to hear, earlier on, Jan was talking about AC fans in door curtains, and also Frank was talking about different applications in condensers and cooling towers. So this is the agenda for today. So really, what's EC technology? I'm going to talk a little bit about that. Applications for retrofitting fans in supermarket. There's many applications, and I'm going to run through just a few of those and explain a little bit about that. I've got a couple of short case studies I'd like to share with you about real life projects that we've undertaken. Yeah, and finally, we'll just discuss the conclusions. So what is EC technology? So, I mean, EC fans are generally recognized as being the latest thing in energy efficient air movement technology. But what is an EC fan and what makes it so special? So let's take a look at one. So first of all, EC stands for electronic commutated, which basically means it's a fan with a brushless DC motor, as explained previously by Mikhail from Corel. DC motors are basically DC motors rely on carbon brushes and a commutation ring to switch the current direction. With an EC motor, the mechanical commutation has been replaced by electronic circuitry. That supplies the right amount of current in the right direction at precisely the right time for accurate motor control. So we further simplified that by using a compact external rotor, as you can see just there as the rotor. With stationary windings and as a permanent magnet inserted into the rotor. You can see that here. Brushless DC motors have been around for years, but they always needed a separate DC supply. So when applications where you only have AC supply, this introduced a lot of added cost and, to be honest, quite a complex situation as well. With EC fans, it's got integrated electronics. So they're connected directly to an AC supply. In addition to performing the commutation, the electronics convert AC to DC and control the fan speed by regulating the power to the motor. So, if I put that simply, DC fans are around 30% more efficient than AC motors because the secondary magnet field comes from the permanent magnets rather than the copper windings. So this really is a major factor with an AC fan is the permanent magnet. An AC motor consumes additional energy solely to create a magnetic field by inducing the current in the rotor. This is only really half the story. The use of modern electronics in controlling the motor has opened up many possibilities for us for reducing the power. The control options, this is the electronics built into the back of the motor. So the control options, we can control an EC fan very, very accurately and efficiently using the integrated circuitry. One of the biggest factors is speed control. And the actual control functions itself. So speed control, it's got a integrated variable speed built into the motor itself. And also from a control solution, you can control this from a 0 to 10 supply, 4 to 20 milliamps. The larger motors, actually even some of the smaller motors now come with Modbus control, so an RSA, RSB connection, and you can literally plug it straight into your BMS system. As we said earlier, there's no need to worry about DC supplies for sensors. So if you wanted to put a sensor straight onto the motor, like a pressure sensor or a temperature sensor, you can simply just connect even a potentiometer to the fan. So there's no triacs, no frequencies inverters, actually no whining noises at all. On an EC motor, under speed control is virtually silent. Obviously from this diagram, there's no impeller. Obviously, a motor doesn't do anything. Frank stated earlier about the different efficiencies. An EC motor is very, very efficient. I mean, the latest versions of our Gen 3 motors are up in the high 90s now. But you know, a motor doesn't do anything its own. It's only half the story. You need an impeller to actually fitted onto the rotor itself. Now, our impellers are very efficient now, but if you take an old axle impeller, maybe, you know, sort of 10 years ago, they were only 25% efficient. Now our modern high blades and our new Axi Ecos, we're up into the 58, 60% efficiency. So there's a great deal of work in R&D on the aerodynamics for EC fans. So, you know, I was talking a little bit before about integrated variable speed control. That's one of the main features of an EC fan. I just want to talk to you about this for a little bit. So we've got a scenario, we've got an 8 fan condenser that all running in parallel. So, you know, a big question, what's the possible variance for the overall, reducing the overall air power to 50%? Okay, so if you only need 50% of the air volume, so on and off, you know, we were talking earlier about on and off. So if you do that on and off, you're going to reduce the power, the actual power consumed by 50%, as you can see in the graph illustrated on the right-hand side. With an EC fan, what we do is we reduce all 8 fans to 50% of their running speed. Now, by doing that, we consume 80% less energy. So that's a terrific saving. So we always do that. There's some other benefits from EC fans as well, and one of them is noise reduction. I think we heard Mikhail talk about that earlier. If you take a 4-fan system, if we reduce the fan power by 50%, so say if it's at, you know, in the colder months in January or in the evenings when the temperature drops, you may want the fans to modulate to a lower speed and optimize the head pressure in the refrigeration system. So if you reduce it by 50%, you just by turning the fans off, so you just turn 2 of the fans off, you're going to get a 50% reduction in airflow, and that results is about a 3 dBA in noise reduction. Well, the EC fans, so like I said before, we run them all at 50% speed. So for a 4-fan system, if we run them all at 50%, so you'll get exactly the same, you'll get 50% reduced airflow. That will give you a 15 dBA noise reduction. And if you take it, there are a lot of convenience stores and quite a few supermarkets now situated in residential areas. That 15 dBA noise reduction, especially in the night times, that's a huge difference. And hopefully all your residents that live close to the supermarkets will be able to sleep without any noise disruptions. So applications for retrofits in supermarkets. There's one in here I haven't actually put, but one of them, you know, I'm just listening to Jan talking about door curtains. In actual fact, we did a project for a door curtain for a major supermarket in the UK. And again, as Frank said, as Jan said, we'd received something like 70% energy reduction. So it's quite a good application. So if you have got door curtains, you can actually retrofit the fans. And it's great to hear you, Jan, talk about EC fans and how you use them in your system. Okay, so first of all, display cases. I think Andreas in the first slides, he talked about EPTA and their case designs. Yes, we supply them with energy saving motors, and just by changing the motor out, it's a 70% energy saving. It's quite an easy, it doesn't have any detrimental effects to the refrigeration system. Actual fact, enhances the refrigeration system. It's a very, very easy retrofit, and the speeds and the airflow can maintain exactly the same as the original fans. Now, I've got a case study later on that I'm going to explain, so I'll go into a little bit more detail about that. When you look at air handling units, most supermarkets will have air handling units of some type. So just by taking out a belt-driven fan without an inverter, if you put a plug fan in with an EC fan, then you're looking at potentially 50% savings. Now, these are not always the case. Sometimes we have seen up to sort of 70-80% savings on some air handlers if we manage to adjust the speed and the airflows and the velocity. But on average, we see about 50%. Evaporators, yes, we can install EC fans in evaporators. You're really looking at about 30% energy saving. The difficulty with gaining greater opportunities for saving energy is the speed control. Normally, evaporators will run at a set speed. One of the things we have been working on is the aerodynamics, like I said previously. So as you can see from this slide, it's got a diffuser built in to the actual EC fan. So we've got quite a few different products with the air diffusers, which means you can get a greater airflow, and then the potential really, I suppose, if you run it with a door curtain, maybe sometimes when it's low usage, you could reduce the speed slightly. So maintain it, and that'll give you a nice constant refrigerant pressure as well. Condensers, yeah, I've got a case study that I'm going to share with you in a few minutes about this. Most condensers now come with EC technology. On this particular one, we've got an axi-top, which is a diffuser, which, I mean, that helps to convert dynamic kinetic energy into static pressure, so making it a lot more energy efficient. So I'll talk to you a little bit about a couple of case studies we've completed with partners. I know, I think Frank talked earlier about taking a holistic view on the system, and I'd like to endorse that. When we take up a retrofit project in a supermarket, we would always work with the refrigeration contractor, and to be honest, as Frank said, the compressors take by far the most energy. So, but I believe by optimizing the fan speeds and the fan, you can then modulate the pressures in the system, making the compressor a lot more efficient. So this is a case study we completed for a company called the Henderson Group in Northern Ireland. Now, this is a very old company. They were established in something like 1897. They're based in Ireland. They've got 70 of their own stores, but they've got over 400 franchise stores as well. So their brand is the Spa, as you can see from the pictures on the right-hand side. This is a great project. This gentleman on the left-hand side is Dr. Glenn Cumbie, and he's the Energy and Sustainability Manager for the Henderson Group. And this chap you can see on the right side is Joe Conway, and he's the Head of Projects at Cross Refrigeration. Now, Cross Refrigeration were the main contractor, and they also act as a consultant within this project. So I met Glenn about 2015, just at a networking event. I had a very simple demonstration unit with a couple of fans in it. Actually, they were display case fans. And he came and had a quick chat over 5 minutes and just, asked me what the benefits were and if he had any of these type of fans in his supermarket. And after a brief discussion, I took a quick trip out to Ireland, viewed their premises, and we decided this was a really good project to move ahead. So as I said, Joe was then commissioned from Cross Refrigeration to act as a consultant in the first instance, and then as the main contractor in the second instance. So Joe visited every single site they had, so all 70. He measured every display case, every single fan. It took him something like, I think it was about 2 months to complete it overall. They decided in association with fitting the EC fans, they would also replace the lighting. So they replaced the lighting to LED. And overall, they made some really tremendous savings. So they had shaded pole AC motors, which are pretty inefficient, small 200 mil fans, and they replaced them with our ECM 8-watt fans. So they went from 38 watts per fan to 8 watts. Now you could say, okay, that's 30 watts. That's not a huge amount of saving. Percentage terms, it's huge. It's about 80%. But if you multiply that by 2,000 fans, that's a huge saving. And it also put less heat into the cabinet, so the compressors didn't have to work so hard, because obviously that 30 extra watts is heat, and that was dissipating into the refrigeration case. So they didn't need to, the refrigeration system didn't need to work as hard. The compressor didn't need to work as hard. Also, they changed, like I said, the LED lightings, what again took out heat from the case. The results from the fan savings alone was £60,000 annual saving. And this was independently verified by Cross Refrigeration, so it wasn't our monitoring solution. It was actually crosses. But overall, when they looked at the lighting from the LEDs, the EC fans, and the reduction on the load on the compressors, they made something like €200,000 saving per year. So it was a very significant project. And it all started off with just a 5-minute chat with Dr. Glenn at a networking event. So over we go. This is one of the slides that they sent us. If you can see, in the yellow was their existing fans, that line. The green is the payback, and the orange is the EC fans, the new fans. And you can see they cross over just before 12 months. So the actual fans was a 12-month payback. The overall solution, including the LEDs and some other modifications they did, I think they put some new controllers on as well, was less than 2 years. So it was a very viable project and a very simple one. One interesting fact is that when we changed when the contractor changed the fans, they needed a couple of adapter plates on only 15%. So out of 2,000 fans, it was only something like 15% of them needed a small adapter plate. And that was just a small metal plate punched out. The wiring was exactly the same. You put 240 volts straight on to the ECM, so there was no extra wiring on this particular case study. So a great case study. Now, my second case study is for a company called Marks and Spencer's. I know you have Marks and Spencer's in the Middle East, and I think there's a couple of stores in Dubai, actually. Again, a very old company. Marks and Spencer's, one of the oldest English companies. They're a big retailer. They're a big department store. Predominantly, they were a department store until about sort of 15 years ago, when they branched out into food. And now their food and their supermarket section is far outweighed the department store. So they're fast becoming a food retailer rather than a department store. Now, this project was initiated by Marks and Spencer and myself as part of their Plan A. Now, Plan A is a sustainability and eco plan that Marks and Spencer developed for reducing wastage, energy consumption, and really they wanted to be carbon neutral by 2020. I think they've had a few issues along the way with some of the programs, and they've now pushed that to 2025, but they're well on their way. I believe they've now hit zero wastage. So things like plastic bags, they've stopped in their shops. They now have all of their energy comes from renewable sources. So they've really taken on board the eco conservation side. So this was part of Plan A. I met their energy manager and sustainability director and their refrigeration contractor on site at one of their stores, and we just walked through one of their stores to see what we could achieve. So we looked at their refrigeration plant, and it was reasonably efficient, but we noticed that they had on and off style condensers. So literally the fans would just turn on and off as the load required, and the compressors again on and off. So it's although it was reasonably new, they weren't controlled particularly well. So we completed a trial in Rotherham, which is in the northern part of England, just near Leeds. And what we did first, we took one condenser, which you can see on the right-hand side, and we replaced the fans with EC. And we left the second one, there was two condensers there, sorry. The second one we left as it was. Now we monitored both of those condensers, or the contractor did, for a period of 6 months. And we made some really good energy savings. The fans alone were saving about 25%, but overall, the system, including the compressor, saved 28%. So it's a huge saving. So on part of that trial, after the completion of that trial, we received an order for 1,400 fans and Axitops to replace all of the fans in 152 stores. So overall, as you can see from the slide, there was 258 condensers, 153 new controllers. Because you know, Frank was talking earlier on about the holistic view. The contractor looked at the compressors as well, and they fitted some new controllers that controlled the head pressure on the compressor and linked to the EC fans. So both went up and down together. And so the fans help to maintain a constant pressure throughout the system, especially, you know, in the UK. I know you don't get so low temperatures in, so much in the Middle East, but in the UK, we get very low temperatures in the winter time. So the fans were able to run at a lower speed and just keep the head pressure a constant. So it was a very, very challenging project. It literally took from the initial trial to the order. I think we started the trial in July, and 6 months later, I think it was January, we got the order, and the whole project was completed in 4 months. By the end of May, we completed the whole project. So EBM, we worked as a consultant and a logistics hub for the contractor. So every day the contractor would come along, they would take the fans from us, they would deliver them to the store, fit them on site, and then an installation team would come along a couple of days later and install them. One of the big challenges, I think one of the presenters earlier said that we weren't allowed any downtime at all. So the engineers had to work completely live. So it was quite a health and safety, you know, there was a couple of health and safety issues there. So what we did, what the contractor did was in actual fact replace 2 fans at a time on any condenser and leaving the whole condenser operational all time. The whole project was completed in store, so at normal working hours. So that was quite a challenge for the contractor. So one of the things we did, we fitted an adapter plate to make sure that the new EC fans will go straight on top of the existing condenser. We fitted an isolator. We fitted electrical cables as well. So all of that was pre-installed onto the EC fan along with an axi top. So it was a very, very quick installation. I think they got it down to a whole condenser within half a day. So a very quick installation. As you can see, the energy reduction was huge, and the payback was less than 5 years. So the annual estimated saving was over £500,000, and that's been verified every year. That's verified, and the savings are still ongoing. Now, on the back of this, we've also done a couple of projects with M&S. I mean, I think it was Andreas that was talking about, you know, the cold aisle, how his wife and his child wouldn't run up and down the cold aisle. Well, Marks and Spencer have a small heater, which is they use the excess heat from their refrigeration system into a small coil, and they blow warm air underneath the refrigeration cabinets. Now, we replaced, they were just on and off fans again, and we replaced those with EC fans. So that was another project that we did with Marks and Spencer's. So overall, so conclusions from my presentation. So, okay, so EC fans definitely save energy, reduce noise level. It allows for greater controllability. It improves the equipment life expectancy. So basically, the bearings in an EC fan will run a lot cooler. And as we all know, bearings are one of the biggest failure points on a fan. So with an EC fan, they run a lot cooler, so the equipment will last a lot longer. Basically, an EC fan life expectancy is on average about 70,000 hours compared to a standard AC fan motor, which would be about 40. Typical applications, it can increase. It depends on the environment. Reduced maintenance, there is virtually no maintenance required on an EC fan. Just give it a wipe over and just check the connections, and that's it. There's no bearings to lubricate. There's nothing else to do. So that's all from me. Thanks very much for listening. We do have an office in Dubai, so if you do have any projects that you'd like us to look at, my colleagues will help you. So, Marcus.